In this video, I wanted to go over a problem in 9.4. So the problem reads, assume that the paired data came from a population that is normally distributed using a 0.05 significance level and d equals x minus y. Find d bar, s sub d, the test statistic, and the critical values to test the claim that mu sub d is equal to 0. So this is my first list, this is my second list, and these are paired datas. Which means I can combine these two lists into one list, the difference list. So that's exactly what I'm going to do here. So I'm going to, in my TI-84, so let's take a step back. We're going to create a list for, we're going to input these two lists into two lists. So we're going to go to stat, edit. This is my X list. This is my Y list. All right, so I already have those inputted. So from here, I'm going to create the difference list. So in order to create the difference list, I'm going to navigate to a new list, press up, highlight L3, press enter, and then in here, L3, I'm going to put L1 minus L2. So second 1 minus second 2. Press enter. This is the difference list. So each of these values corresponds to the difference between these matched pairs. So for example, 7 minus 10 gives me negative 3, 10 minus 11 gives me negative 1, and so on. All right, so once I have this difference list, I can run one var stats to get d bar and s sub d. So that's what I'm going to do. So second quit. So quit out of that, go back to stat, go to calc, one var stats. I'm going to put L3 here, right? So if it wasn't there, I'd do second 3 to get L3. Frequency list is not needed. We don't have one here in this case. So we're going to click calculate. So X bar, which are really, these should be D's, right? D bar would be 0.62. And S sub D, which is the sample standard deviation, is S sub X. So that's 2.33. So I'm going to write those down. So D bar, 0.625. S sub D is 2.33. Okay, and in this case, this is the critical value. I'm sorry, the test statistic, this is the critical value. So to get those, to get the critical value, I can run a t-test on the difference list. So let me repeat that. Once I get the difference list, I can treat it like it's one sample and run a t-test on that difference list. All right, so let's go back to the calculator. We're going to go to stat, go to tests, go to t-test, press enter. We're given data, and we're going to run a t-test on list 3, which is where we put the difference list. Let me take a step back. I forgot to mention that the claim is that mu sub d is equal to 0. The null is always that mu sub d is equal to 0. And the alternative, in this case, because the claim contains an equal sign, the null on the alternative is the opposite. So the alternative is mu sub d is not equal to 0. All right, so that's going to be helpful because we need that to select the correct answer here. So mu sub 0 is always the value that's on the right of the claim or the null and alternative. So that's 0 in that case. List 3 is where the difference list is located. Frequency we're going to leave as 1. This is the alternative. Alternative is not equal. From here, click enter. T, which is the test statistic, rounded to 3 decimal places, is 0.760. So 0.760. And then lastly, these are the critical values. So for the critical values, the easiest way to find the critical value, in my opinion, would be to use the table. So there's a couple things or 3 things you need to know to find that. So you need to know what kind of test it is, whether it's a one-tail, a two-tail, a one-tail, a left tail, a right tail, or a two-tail. So left tail and right tail is a one-tail. So in this case, again, if you guys remember, that is determined by the sign in the alternative. So because the alternative has a not equal sign, it's a two-tailed test. If it has a less than sign, it's a left tail. If it has a greater than sign, then it's a right tail. So in this case, it's a two-tail. And then alpha, the significance level is 0.05. And lastly, we need the degree of freedom. So df is always, or not always, but in this case, n minus 1. N is the number of pairs of matched data. So that's 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 1, the degrees of freedom is 7. So we need to know that it's a two-tailed test. Alpha is 0.05, degrees of freedom is 7. Once we have those, let's go over to the table, the t, critical t values. It's an area for two tails. Alpha is 0.05, so we're in this column. Degrees of freedom is 7, so we're in this row. The intersection between this row and this column would be 2.365. So the critical values are positive plus or minus 2.365. All right, so hopefully that helped. If, again, as always, let me know if you have any questions.